Hello everyone. In this video, I am going to do differentiation from first principle. So here is the question: fx equal to the function in x equal to 2x plus 3, and we have to differentiate with respect to x because our function is in x, so that we will differentiate with respect to x and we will use the rule first principle. So differentiation from first principle. So differentiation is the process of finding the slope and gradient. So when we will differentiate any function, we will find the slope and the gradient. So we are going to use the differentiation from first principle. Let's write down the formula first, how to differentiate from first principle, and we will use this formula here. So here is the function fx. So we will write when we have to differentiate anything, we will write any function in fx, we will write f prime of x equal to, this is the formula I am writing from first principle. So here limit equal to h tends to 0 f of x plus h minus fx over h. So we will use this formula to differentiate the function fx equal to 2x plus 3 from first principle. So we are going to use this formula. So let's start. So in this formula, we have fx plus h and fx. So for fx, nothing to do. We have fx. We need to find fx plus h. So let's find it out. Fx plus h. So first write it down fx. So fx is 2x plus 3. Now we need to find f of x plus h. In place of x, here is x and here is x plus h. So in place of x, just sub in x plus h. 2 times in place of x, I am going to write it down, x plus h plus 3. And then multiply it and open the bracket. So 2 times x plus 2h plus 3. So this is your fx plus h. Now we have fx plus h, fx, and here is h. So write down the formula again here. F prime of x equal to limit h tends to 0 fx plus h minus fx over h. Write down limit h tends to 0. In place of fx plus h, just we found out here, write down 2x plus 2h plus 3. And here is minus sign, minus fx. So fx is 2x plus 3. So keep it in the bracket because minus sign is there. We will open the bracket now and over h. Here it is, limit h tends to 0 equal to limit h tends to 0. So 2x plus 2h plus 3. Here you have to multiply by minus sign and open the bracket here. So minus 2x, it will be minus 2x there. Then minus plus minus 3 over h. Now limit h tends to 0. And see here, this is plus 2x, this is minus 2x. We have to cancel this, and plus 3 and minus 3, we will cancel this. Here we have left here 2h over h, and then we can cancel it out, h and h as well. So here we have limit h tends to 0 and we have here only 2. So it means this is f prime of x, which is differentiation, f prime of x equal to, we have 2. So this is your answer. Now let's do one more question. From same first principle. Now we have question here, differentiate f of x equal to 3 plus 2x minus x square with respect to x. So let's differentiate it. So we have fx is 3 plus 2x minus x square, and you know we need here fx plus h. So we will sub in place of x, x plus h. So 3 plus 2 times x plus h, then minus x square. It means we need to do x plus h whole square. Now calculated this one, simplify it. Now this is open the bracket by multiplying by 2. So 2x plus 2x and minus, and we have a plus b whole square thing is there. So write down the formula of a plus b whole square here, which is a square minus 2ab plus b square. So write down here x square, this is here plus, so plus 2x h plus h square. Now simplify more, 3 plus 2x plus 2x, here it is, we are multiplying by h here. So we'll write it down here h. So here it will be h. Now we have to open the bracket by multiplying minus sign. So multiply by minus sign each term. So minus x square here it will be, then minus 2xh, then minus plus minus h square. Now see here if we can cancel it out anything. So we can't cancel it out anything. Now write down the formula of first principle, which is f prime of x is equal to, this is the differentiation sign, limit h tends to 0, fx plus h minus fx over h. This is your formula. Now h tends to 0. In place of fx plus h, we have to write it down this one. Write it down 3 plus 2x plus 2h minus x square minus 2xh minus h square, minus we have to write it down fx. So fx is this one, our function is. So inside the bracket write it down because this is minus sign, otherwise we will do mistakes. 3 plus 2x minus x square over h. Now limit h tends to 0, simplify it this one, 3 plus 2x plus 2h minus x square minus 2xh minus h square. Now multiply by minus sign and open the bracket here, this one separately. So minus 3 minus 2x and then minus plus minus plus x square. So this minus will be plus over h equal to limit h tends to 0. Now see here, if anything we can cancel it out. So this one is plus 2x and minus 2x, so we can cancel it out this one. Then we have plus 3 and minus 3, we will cancel it this as well. Now minus x square plus x square, cancel it out this as well. Now we have left here minus 2xh minus h square over h. Now what we will do here, limit h tends to 0. You can see in both the term we have h here. So let's take h as common. So take it out and we have left here minus 2x minus h over h is here. So 2xh minus h square is there. I left here So here it is. Here we have 2h here as well. 2h, this one is here, and then minus 2x h, and then minus h square over h. Then we have in all the three terms we have h here. So we will take h common here. So what we have left here, if we take h common here, so we have left here h goes out, so we will have 2 minus 2x and then minus 1h left here. Now sub in here, this and this h cancel. I'm going to do it here. Limit h tends to 0, and we have here 2 minus 2x minus h. Now you have to put h equal to 0. So now we have left here 2 minus 2x minus 0. We have limit h tends to 0. So answer will be 2 minus 2x. So this is the differentiation of first principle, and we have answer here 2 minus 2x. This way we will differentiate any function from first principle.